So I'm Antonio Lerario. I'm a professor at SISSA. I'm a mathematician. And first, why am I here? I think this happened, it's a consequence of a conversation I was having with Sebastian. It was a spontaneous conversation. And he just brought up this conference, and he said, why don't you just come and report about what you think on the topic. I wasn't expecting to give like a talk in front of this audience, and I did not have much time to prepare slides. I did an attempt asking ChatGPT to, I wrote some notes yesterday to put them into slide format. I think it didn't work, so I was not happy. I'd rather talk this way, okay? It's not gonna be long. I'm just gonna share my experience. That's based on our conversation. I'm going to expand on a conversation that I had with Sebastian. So the topic here is, if I understand correctly, is generative AI creative? And maybe I can give my point of view as a mathematician, okay? Which connects to, is a mathematician creative? That's my question, if you want. And short answer and honest answer, for me, it's no. So generative AI is not creative, but neither mathematicians are creative. That's my short answer. But I want to elaborate a little bit on this, and I don't want to be provocative. I really want to be constructive, okay? So I have a very weak view of mathematics, a very weak metaphysical view of mathematics. I don't think mathematics is different from any other human language production, okay? I don't think mathematics is much different from a conversation we are having, okay? It's just that the rules that we adopt are stricter, apparently stricter. I don't think there is any oracle or any real truth. That's my point of view, okay? If I have to set up a conversation which is at some high level. So honest conversation, I don't think this is anything of this is happening. But for practical purposes, I am a Platonist. So when I do mathematics, when I do science, I like to think that this happens. I like to think there is some magic. It's some sort of like a force that drives me while, so that's my short answer of my point of view. So it sounds very skeptical at the beginning, like there is no truth, everything is rooted in language, conventions, actions, gestures. But in practice, I think if you admit that everything, we are constrained to language, and language is just, as you were maybe asking about the Chinese room dilemma, you cannot explain a language by phone, right, to someone. If you just accept that language is made on pointing at something, okay, that's the metaphysical side, so let's adopt some common sense operative point of view. I'm okay to just talk about creativity and mathematics, okay? But let me elaborate a little bit more. So first, what is creativity? I was searching on Oxford Dictionary what it's written. It's written the production of ideas and objects that are both novel or original and worthwhile or appropriate, that is useful, attractive, meaningful, or correct. I mean, you see that definition is quite shaded, right? There is a lot of room for interpretation, and that's not a coincidence. For me, it's clear that it has to be shaded. So I think when linguists write dictionaries, they only, they take for granted 10,000 words, which is more or less the ground knowledge of an average person. And then they use these 10,000 words to explain all the other words. So the dictionary is, of course self-referential. You cannot, there are some words you cannot explain. That's the same thing that happens in mathematics. There are some notions you cannot explain. And how do we use them? It's just based on like conventions, maybe a mutual agreement that for me set means something. It's based on experience. At some point I was told that this is a circle and someone made a picture and now my mind thinks about this, that this is a circle. There is a lot of convention, okay? This is also what happens in language. And so I don't like, I mean, if I want to be honest, I want to adopt some operative definition for now, for trying to answer, is generative AI creative or are humans creative? So you could say it's something that generates surprise. That could be something. In the act of making science, whatever that means, it's just about common language, okay? I hope it's clear that we cannot like define what means science, we cannot define the language, but let's adopt this practical way. I think it's something that generates surprise. Well, we might agree, like we're doing something, and when there is something creative, like, oh, that's quite surprising. Maybe you've done something, but it's just something you cannot explain. That's my point of view. I will get to mathematics in a second. So there is one thing that I think it's related, which is the notion of randomness. Where does this connection comes from? Is it like some deterministic connection that happened in your brain, or is it some really like there's some intuition or something? And again, like what is randomness? In mathematics, we define randomness as lack of information in some sense. So there is this experiment, you toss a coin, and you think it's, I am tossing a coin, you would call this a random experiment. If you have to just predict the outcome, that's fairly random. But now suppose you have a little bit more information. I'm tossing the coin, and you have access to a camera which is pointed there. Can you predict the outcome? Okay, there is one more camera out there. There is one more camera out there. So the more information you have, the less this is random. Okay, I mean, this reminded me when I was thinking about also what we do in mathematics. Like there is this, the Library of Babel. I don't know if you know this short story by Borges. Do you all know this? Or is it, okay. It's a great short story by Borges, one of my favorite authors. So in this, it's 8 pages maybe, okay? So, and he conceives a universe which consists of a library. So that's the universe, okay? It's made of rooms, hexagonal rooms. There are geometric reasons why they need to be hexagonal, or hexagonal is allowed. They could not be pentagonal rooms. Hexagonal is important. And in each room, there are shelves. In each shelf, there are books. And in each book I think has about 400 pages. Each page has about 30 lines. Each line has about 20 characters. And they discover at some point there are about 25 characters. I mean, in the story, these numbers are precise. I'm just remembering. And this is it. And in this library, there is everything. All possible in these books, there are all possible conversations. This talk backward. This talk, or at some point, I just go crazy and just start talking Chinese. There is everything, every possible combination that you can imagine with these things. Okay? So the distribution of information in Borges' library, it looks like uniform. That's the major dilemma that the explorers have in the library, that they do not have access to interesting information. I think that distribution of information in the world, it's not really uniform. I think like what people call manifold hypothesis or related things are more about like information not being uniformly distributed, but being distributed according to something, and this something is the pattern that we try to explore. So I have the view that like when we do science, when we do mathematics, I do mathematics, I'm exploring some region where all possible sentences exist, all possible mathematical sentences. Some of them are conventionally more interesting, some of them are conventionally less interesting. Okay, so that's the point of view. And let me get now to the point. This was just preliminary. So what is mathematics? I think mathematics is just a linguistic process, okay, which is based on agreement between I see many mathematicians here in the room, so they can come back to me and say this is bullshit. I don't believe it. So when I write a proof, for me, it's clear that I'm mimicking past proofs that I've read. It's clear that someone has taught me that when I start a sentence, for every epsilon, there exists delta, is a very likely next step of this sentence. It's clear that I consider something interesting if there are papers that I've read, published in good, so there is a lot of influence that comes from my ordinary life experience. Interesting means, okay, I've read some paper which is published in a good journal. It creates me some emotion, okay? I define this interesting. I have been reading a lot of papers, I had conversations, and I start mimicking the act that other mathematicians do. I read a lot of papers, not as many as physicists. I think I've read recently some interview to some physicists, how many papers do you read per year? And physicists said something like 80 or something. And mathematicians were quite more modest, 6. So that's 6 is a lot, by the way. Reading 6 mathematical papers, it is a lot, seriously. So, but I have read books, I have read things. So I have learned that there is some agreed language, that there is some convention. And I think mathematics is just like a very deeply constrained game, okay, where there are precise, more precise than human nature language, and that's it. And creative is just something that is just this arc that we cannot explain. At some point, we generate surprise in what we read. We have some more. We think it's progress, but I really believe that there is no metaphysical act. There is no. In this sense, for me, a generative AI is as creative as we are. I don't perceive a difference in this sense. Yeah, I wanted to give some more examples to convince you. First of all, when we prove a theorem in mathematics, there is no oracle. There is not someone saying, "Wait, the theorem is proved." Okay, fine. No, it's proved. It's proved forever. It's proved. No, it's not true. I mean, it's proved when the mathematical community agrees it's proved. If we read back the proofs that Gauss gave of the fundamental theorem of algebra, we would not accept them nowadays. So it's what means that a theorem is proved? It's a convention. Okay? There are some big theorems, again, something we call community, big theorems that are considered to be proved, like long theorems, like Poincaré conjecture, okay, a result of several papers. Last was name Perlman, but they're very long papers. There is very few mathematicians who can master and understand everything that's going on. We rely on those mathematicians, and we believe these theorems are proved. But if you ask me, would you go, if there is any, in front of God and say they are proved? No, no, I would never say they are proved. I would just say, in my community, we believe they're proved. Okay? And if you ask me, was this a result of a creative process? No, I would never like think it's. So if I need to have a conversation with some God-given entity, that's what I say. I want to be honest. I don't think this is. It's just we believe these are things are proved. Again, there is a same story for Fermat's theorem, and basically, so what is proving a theorem? It is the act of convincing your community of some linguistic statement. So there is some cognitive process, the intention. You want to convince your community, and then it's approved. What is creativity? Again, it's just finding, it's the result of this probabilistic random, I don't know how to explain. It's what we cannot explain. It's the way we cannot explain how this process go. I don't want to be long. I think I should stop in a few minutes. I just want to say a couple more things. And one thing I was thinking about this, also in referring to our conversation, it's what I would call the Platonist dilemma. So if I have to give an honest answer, it's what I said. So we're not creative. Generative AI is not creative. Language is just a convention. This conversation is just a convention. I mean, it's empty, right? Because it's based on mutual agreements, words, things I've pointed out. This is a table, okay, something like this. But in practice, I like to be Platonist. I mean, if I had to adopt this point of view, I would be stuck. I don't think I could do anything in my life, okay? But in practice, I think it's very powerful to be a Platonist, as I said, as a driving force. So as a mathematician, thinking of myself, I'm skeptical. No metaphysical view, weak mathematics, absolutely nothing. But as a mathematician, from the operative point of view, I have a very strong, when I'm doing mathematics, I have a very strong view. I like to be romantic. I like to think that there is some world out there. I like to think that there is beauty. I like to think that I am creating. Otherwise, I think I would be very scared. If I'm not creative and there is nothing, I don't think I would have energy to keep going. So I think it's honest to adopt this point of view and also practical. And last thing, I wanted maybe to, going back to the definition of creativity, I think it is a useful label. So it's a useful label for the type of, in this community, in this room maybe, research or type of outcomes we want to continue to explore. That could be some operative, and it could be meaningful. I like it to put it this way. So some useful label of things we cannot explain. There is no magic, but if we want to keep going, I think we need a little bit of magic. Otherwise, I want to stop here. I really want to have feedback from the audience. This was the conversation, Sebastian, right? Yeah. There was more, of course, but I need to stop myself because I know that otherwise I would just start talking about random things, okay? Okay, so let's stop here.
Perfect, thank you very much.
Thank you.
You'll get some.
So I'm curious how you think about two places where, let's say, external evidence is in some ways confirmatory of mathematics. So one of these is the unreasonable effectiveness of mathematics in the natural sciences, and the other one is the kind of more recent development of formal theorem proving, both of which are kind of these interesting examples where there are these, both of them are sort of mechanical things happening in the world that are not inside of our heads or not in our communities. You know, one of them is just the way the world works, and the other one is the way that the computer is sort of chugging along mechanically to produce a verification. But both of these seem to be consistently confirmatory of the kind of results that you produce in, you know, this kind of sociological way. So if there's no metaphysical dimension to that, how do you think about the fact that that seems to keep just working and working and working?
I mean, I sometimes think about this answer. I just look at the outcome. It's great. It works. So operative, it works. So that's good. Let's keep doing it. If at some point we would see that like it would not help us anymore in I don't know, if our goal is to be happy. I don't know. If at some point this is not helpful anymore, maybe we should adopt this paradigm, the scientific paradigm. That's what I mean. Otherwise, I just observe that it works. But to be honest, if you want, this goes a little bit back to the question, how did language originate? I think it's the reason that why it works, I think it's because mathematics originated from, again, it's a form of language. Language works, right? We're communicating right now. I think you're nodding. I was nodding. I mean, it's clear that we don't, maybe we have, I'm Italian, maybe you're not Italian, we have different common, but it works. We have the feeling we are communicating. And language was, I mean, arose maybe as in this way, right? Because people just, oh, this is a shoulder, head. It was useful to use the voice to communicate something, to record it, etc., etc. And I think mathematics was born the same way. People were just having spatial intuition. And then they started to frame it into language. And it's clear that if these are the roots, the questions we will pose in mathematics will be interesting. Let me give you an example, because I mentioned Poincaré conjecture. Poincaré conjecture is a conjecture in topology. Okay? It was, okay, you can phrase one-dimensional, two-dimensional, three-dimensional, four-dimensional. One-dimensional, it's not really true, but okay, it is true. Okay? Two-dimensional, it's easy, because two-dimensional manifolds compact are classified. Three-dimensional, it's where it was phrased. Four-dimensional, kind of difficult. Five-dimensional and on, it was proved earlier by Smale in the 60s. Okay? So Poincaré conjecture dimension 5 and on, proved in the 60s. Poincaré conjecture dimension 4, proved in the 80s by Friedman. Poincare conjunction dimension 3, so when it was formulated, proved 2010, something. So I think it's not that it was more difficult, it was the right question. It was formulated using our language. Are you a physicist, a philosopher? Physicist. Hilbert spaces, okay? Hilbert spaces are infinite. No, they are inherently two-dimensional. Addition of two vectors, multiplication by scalars, and scalar product, it's a two-dimensional fact. Okay, then we think of it as something like that lives in, but it's really two-dimensional. So whatever question we come up with that are based on these, they will be interesting and they would be effective. That's my view, okay?
Hi. I somehow thought that it's possible, both in maths and in language, to actually create new rules and then play
To create?
new rules and then play by them. So why would you say that is not creative?
Again, it's about the definition of what do you mean. So if creating is generating new sentences, if we agree on this.
New rules,
Oh,
not
but
new
even,
sentences.
I mean, it is, that's a good point. I like this question. I need to think about. Okay, I need to think. I wasn't thinking about deciding what are the rules to move on, but I can throw it back to you, okay? How did you end up creating these rules? Did you just generate random rules, or was your intuition, let's see, that theorem, maybe if I change the axioms, because maybe I have some physical experience, and then you pose a new rule. Was it really creative, or was some process that in your brain you cannot explain that brought you to that? I think it's a second option, but in practice, yeah, you see my point, right? It's great that we can create new rules in practical terms. Are we really creating new rules? Not really sure. That's what I'm saying. Would you go in front of God and say, I created a new rule? You bet. You either go to hell or to heaven with this question. What would you bet? Do you say you created, or you said, I was led to this new combination of words and symbols? Right? It's delicate.
Yeah, I think I have a symmetrical question. You said that mathematics is a linguistic process where language is constrained, and this is sort of not very different from AI.
Yeah, I agree.
And, well, basically in AI, the language is constrained by statistics when you have next token prediction. I have two questions here. First, in mathematics, the language is constrained by what? And second, contrary to AI, in mathematics, you can break these constraints, and isn't this a creative process?
First question, then you will repeat the first one, okay? The second one. First question was like, what is the constraint? Convention. Just convention. The constraint of the mathematical language is the same, it's an apparent constraint. It's the constraint of what we, community, think is correct and proper. Just convention. The constraint that Gauss had is not the same that we have nowadays. Here is an experiment. If you think about sort of like the Turing test for a mathematician, okay? I think right now the community can still detect if on the other side of the bot there is a mathematician or not. But as soon as the language that is used is approved by the community, I think that's the constraint. That's it.
But what would be the consequence of breaking these conventions?
I mean, first of all, maybe
you may lose your job.
So, of course, that's clear. I already foresee this, okay? I have a permanent position, so I'm in an Italian institution, so I'm quite more relaxed, okay? If I was in the US, I would be a little bit more scared. But yeah, I agree. So I want to now, my answer, would be, you're not breaking the rule, etc., etc. But let's be practical, otherwise it's too skeptical. Do you see what I'm saying, right? Metaphysical answer is you're not breaking any rule. There is no rule. It's just a convention. You think you're breaking some rules, but it's not. It's just your lack of information, or just the way you experience this thing that creates surprise, that it's magic. Okay, but it's always the same answer. That I think you understood what is my point. But in practice, yeah, it's great. If you break the rule, whatever you call it, and it works and it gives benefits to the community. By the way, mathematics benefits not necessarily the word. It's maybe just the mathematicians feel like happier. Oh, wow, that's great, that's beautiful. One thing which is related to your question, you might lose your job. I don't think mathematicians are doing mathematics for the world. Let's make it clear. They're doing for themselves. So that's completely clear to me. And if breaking the rule means that we are more excited and we are more happy because this is something new that looks more pleasant, looks more beautiful, that's great. In science, maybe in physics, I don't know, but let's say in engineer or some other really applied science, if breaking the rule means a better benefit, I think that's great, and this is how it works.
Well, I mean, I'm a bit skeptical about your answer, because if you break the rules of mathematics, then it turns out that you lose the empirical success of mathematics. So it seems that these rules are not just conventional.
If you think of mathematics as applied to the real world, that's one thing. If you think about the empirical success of mathematics applied to mathematics, I think you don't, so empirical means, you see my point? So if mathematics is applied math, I might be okay, but then I don't think you can really break the rules because you want to compare with what's out there. But if mathematics, if the empirical part of mathematics is applied to other areas of mathematics, or maybe applied to mathematicians, just make them happier, I think if you break the rules, you have a chance to make them happier. That's how historically it developed, right? You look at like history of mathematics, at some points mathematicians became happier when new paradigm arrived. I think one thing which is underestimated is the progress that mathematics has done in 20th century. Compared to other sciences, I really want to be honest, it's huge. It's just very difficult to communicate it to everyone, right? I think mathematicians have become way more happier in 20th century. There is really a lot of new things to learn. Like in this sense, if empirical is applied to mathematicians, this was a result of breaking some rules and like exploring new, right? New. I really want to be with my feet grounded on the floor.
Thank you.
Well.
Thank you. This was beautiful. I wanted to be sure I understood. You described this kind of blue pill, red pill situation. Like the reality is that there is no truth, so to say, no real mathematic objects out there that you have to find out. But you like to think that there are. You like to think about a Platonist, and that allows you to think that you can be really creative. Shouldn't it be all the other way around? I mean, if you're a Platonist, and if you think that the mathematical truth is out there, you can only find it. You cannot create it.
Well, yeah. I mean, in this sense, I agree, yes. So maybe creativity in mathematics, you can phrase it, I agree with you, totally agree with you. I was more suggesting a romantic idea versus a skeptical idea, but I agree. If I say Platonist in a strong sense, I don't create anything. Maybe I discover something. That's okay. That's okay. That's just how I like to perceive my act. But I totally agree with you. So that's.
Yeah, I just wanted to just maybe what you describe as the skeptical cynicist idea. Maybe it's more romantic than the Platonist idea. Maybe there is a beauty to it.
Okay, I need to think about it. I need to think about it. But I agree. So you can phrase it. There is a weak Platonist, which is there is truth, and we discover paths to the truth. That's halfway between it, which is, so we discovered the paths, like the sequence of combination of words that lead to that theorem. But you can be a little bit stronger. That's also part of the truth. So you're not even creating this path. Sorry, you create the path or you discover the path to something.
But maybe the Babel example by Borges is the middle way between the two, because it's precisely that. I mean, everything is already there, but it's up to you to make sense of it. It's up to you to create patterns that make sense and that work.
I want to think about what you're saying, okay? I'm just, I don't think my position has to be written in stone. I like this, and I agree. Also, the way I translate my attitude, it's shaded. And I don't want to think too much about that. I want to keep it enjoyable. So I don't want to say at some point, oh, well, maybe I should change. Now I enjoy it a lot. I like to keep it this way. Am I discovering? Am I exploring? Am I creating? It depends. Sometimes I just, oh, that's true. Sometimes, oh, I created this proof. As soon as I enjoy, right? But this is all in the practical. In the metaphysical, let's just be honest. Yeah.
Thank you for your presentation, for your talk. My question is, whenever we are studying mathematics for AI, either
Sorry, can you start again your question?
whenever we are studying mathematics for AI, either at undergrad level, master's level, or even at PhD level, the professor always say that AI is nothing but it's mathematics. Either it's stats, probability, distribution, and all those things. If AI is nothing but mathematics, then why can't we say with big heart that AI is creative? If mathematics is creative, then AI should be creative too.
Yeah, I see. It's just, that was my point, more or less. So, to the net outcome of just looking at the result, so a sentence, okay? What applies to us and what applies to AI, I think should be the same.
Yes.
That's, then, if you want to call creative our process, then I would call that one also creative. I don't think it is, but in practical terms, yeah, I think in practical terms there is also magic between magic in the AI. It's kind of clear. I mean, I was used to ELIZA when I was a student, and that would not pass Turing test. I didn't feel the magic. When ChatGPT arrived, I was like, what the heck is happening? I was really stunned, right? It's just something new, something magic. But magic because I want to pretend it's magic.
Okay.
Okay.
Thanks very much.
Thanks you guys. Thank you.